Okay, welcome. Welcome to part two of our six-part series on cloud native application development on the Oracle Cloud Platform. It's 5 o'clock Central European time, and I think we have people joining in from, well, not all across the globe, but a long way across the globe. And I know it happens to be 10 a.m. in Mexico City. So welcome, Rolando. Rolando Carrasco and myself, Lucas Jellema, will guide you today through functions. And next week, we'll talk again about functions, and then we're going to talk about some of the more advanced functionality around functions and using other cloud native services. But today, we're going to do the general introduction. Some of you probably attended last week's session. If you didn't, the recording of that session is available, and the link to the recording can be found in the chat window. We will provide a link, of course, to the recording of today's session, although if you're here, you may not need that recording. If you have questions, please write them in the Q&A window. When I'm talking, Rolando will try to watch over the Q&A window and vice versa when he is presenting. So hopefully we can answer all your questions. As I said, today is about functions. And it's of course all about Oracle Cloud. And like I said last week, we want to tell you so you can hear, we want to show you so you can see, and then most of all, we want you to do Oracle Cloud yourself. And we provide the hands-on scenarios that we will demonstrate and introduce, but then you can do them yourselves on the Katacoda platform. So expect from us an introduction to OCI services, a demonstration of these services, and an overview of the guided hands-on labs that you can then do yourself. After we complete our demonstrations, we will be available for another 45 minutes to watch over the Q&A window to answer any questions you may have. So we will be using again the Katacoda platform, and today we will focus on these three scenarios: an introduction to Project FN, then serverless functions on Oracle Cloud. That's basically taking Project FN and taking it to the cloud, and then the API gateway on Oracle Cloud infrastructure to expose, for example, functions or other resources. The link you see on this slide is the link to the online Katacoda environment. And if you go to the link, you will find all scenarios, not just the ones for today, but also the ones for last week and the ones we'll discuss in the weeks to come. So last week, we gave you an overview of all the OCI services for cloud native application development. Today, we'll focus on a few of those. So we focus on functions, and functions are the core element, I would think, in any cloud native application development effort. Although you can also use containers, as we discussed last week, and we'll show in session 4, I believe, when we talk about the Oracle Kubernetes engine. And of course, you can just use compute servers with VMs, but functions are the real cloud native way to go. And we will expose the functions using the API gateway. That's another important OCI service under scrutiny today. Next week, we'll connect the functions to object storage, to the NoSQL database, and to streams, both to publish events and to consume events. So that part on the right side, that's for next week. Today, we focus on Project Event, functions on OCI, and API gateway on OCI. So this is maybe a bit much, this slide. Maybe I can better go to this slide. When we talk about Project FN, we talk about an open source project that implements serverless functions in a framework, and the function implementations are done using Docker containers. And because these containers are fairly generic, the content of those containers, the runtime you use for implementing those functions, is for you to decide. And there are some out-of-the-box implementations available, but by and large, you can decide yourself on the implementation of the function that you will use. The function then running in a container, deployed through the event framework, and the event framework knows where that container is, how it can be reached. You can invoke functions through the framework. Today, we'll mainly invoke functions through HTTP requests and through the API gateway. In next sessions, we'll see how functions can be triggered in other ways as well. Of course, in a function request, we can indicate a method, we can specify headers, we can specify parameters and a body, and all of those are available inside the function for determining the functionality that the function should execute. Whatever is sent in the HTTP request will be available inside the function, just like it is in a servlet, for example, or in a node application using the Express framework. It's all very similar. And now I see I'm using the wrong slide deck. I'm very sorry about this. And I can show you a much better one. So to repeat some of the things I already said, out-of-the-box support for many runtimes. Custom Docker containers can be used as well. So you can basically implement a function any way you like it. And Project FN, as I said, is the foundation for serverless functions on OCI. Okay, so these are the main reasons why we have included a Katacoda scenario for Project FN, because it's what we build almost anything else on top of. So what does this Katacoda scenario entail in this case? Well, first of all, we need to get our environment ready. This is all part of the scenario. And in this case, we are not going to go against Oracle Cloud. This is the one scenario where all you need is a Linux environment and the installation of FN, both the FN client, command line interface, and the FN server. I will show you this in a moment. Actually, maybe it's best if I start it right now. So here's an overview of all our hands-on scenarios. And here I start a scenario for an introduction to Project FN. And what I'm doing is exactly the same thing as you should be doing later on. So now I start the scenario, and at this point, the FN server and client are being installed. And we have to wait a little. So this is a good time for me to return to the presentation and to explain a little bit more about the scenario. In the scenario, you will create a function and an application, and a function needs to be part of an application. An application is a way of clustering the functions. Then we will deploy the function and run it. That basically means that in our scenario environment, a container image will be prepared and a container is started based on that image. And then when we invoke through the FN framework the function, a call will be made to the container. We don't actually see the container ourselves. It's good to know that it's there, and at some point when you're deploying, you need to know about it, but in the actual interaction, you're not aware of it. The scenario also includes the implementation of a function using a custom Docker container, and also implementing a function using a GraalVM-powered Java native image, which is extremely lightweight and has extremely short startup times. And that's where Java serverless becomes viable. Java by itself tends to be fairly large and fairly slow in starting up. Using GraalVM really accelerates that. So I showed this slide before. This is the FN request function handling. And let's now go to the scenario again. And at this point, when I execute the Docker PS, I see a Docker container is running. This is the FN server itself. So FN itself is running inside a container. and it will deploy the functions as containers inside that container. So here we are working with Docker inside Docker. And again, you don't really need to know, but that is what is going on. So in this scenario, we can check the FN version, and we see both a client version and a server version, because now we have FN server running locally. When we are dealing with functions on the Oracle Cloud infrastructure, we won't have a server version because the Oracle Cloud is the server, which has a version, but it's not a local version. We can work in different contexts. So we can build functions or develop functions in a local context, such as the one shown here. In the next scenario, Rolando will show you that there will be an Oracle context, which is connected to the Oracle Cloud environment. So I'm specifying I want to use the default context, but that isn't really meaningful because it's the only one available. And here you will be setting, and I'm setting now, the registry I want to use for publishing my function container images to. And in this case, I'm not actually publishing them anywhere because I'm working locally. In the next scenario, you will have to specify the Oracle Cloud infrastructure registry for this. And again, a list of my contexts, and there's still only one. The asterisk indicates that it's the current one, the one that I'm using. And now I'm ready to start creating a function. So let's clear the page. And this is the statement I use for creating a function. Fn init, create a function called hello, and the runtime to use is Node. I could have specified Java, I could have specified Go, I could have specified a number of other runtimes, but in this case, I'm picking Node. And a directory is created, and in this directory, 3 files are created. The func.yaml is a file you will find with functions in any language. And it specifies a number of things that are specific to the FN framework. So basically, it indicates the runtime, the name of the function, and the way how the function should be invoked, should be started. The implementation of the function, that's in a file func.js, and package.json is a file that you will find in any Node application. So func.js, this is what we get generated out of the box. And typically this will not be the function that you want to use, but for now it's an easy example. It's an hello world function, and it will return hello and the name that's sent into it as an input parameter. So I need to create an application in order to be able to deploy my function, because the function needs to be part of an application. So here's the application, and here's the deployment. And at this point, you will find that Docker containers are being used. So at this point, a container is started in which my function is being built, and the result of that build is also a container. It's now done, and that container is ready. Successfully created function. And if I take a look at all my Docker images, I will see that a new Docker image has been created 8 seconds ago. Well, that's the implementation of my function, and it's fairly sizable, almost 76 megabytes. That shouldn't really bother me, but well, that's just the case. I can ask for a list of applications. There's one application, the one I just created. I can ask for a list of the functions in that application. There's one function in the application, the one I've just created. And here is how I can invoke that function. And it gives me hello world. That's not really a surprise, is it? Here, sorry, next step, I invoke the same function, but this time I'm passing in a body. The body is a JSON object in this case. The JSON object contains a single property. The property has a value. The value is your name. And when I invoke it, I get hello, your own name. And you won't be surprised that if I change the now I am surprised. What did I do wrong? Oh, I missed the quotation marks. Now, in a room full of people, you would all have been shouting out at me. And now I have to do it myself because you're all muted. So this is how we create a function. Over here in the scenario, we have described how you can take an existing node application and wrap it as a function. So you don't have to provide the implementation of your function in this one file, but you can include an existing application as a module and invoke it. Okay, so that's the basic scenario. Down here, you get instructions for debugging and logging. So by inspecting the function, we get an invoke endpoint, and that endpoint is a URL, and we can invoke the function. First, I get the endpoint into a Linux environment variable, and now I make a curl call. So I'm not using the fn client to invoke the function, but I'm making a curl call to invoke the function. And again, I get what? I get a fairly standard reply. Hello. Here you get an instruction of adding a specific type of trigger to the function. You can just read it. And here is an explanation of how you can make use of the context of the function request. So we by default, we only get the body that's sent to the function in the request. But if you want to have access to the header variables, for example, and to the fn context, you can make a few subtle changes, actually just one change. And now our function will also get the parameter CTX, and this parameter contains the header. In order to see what's being passed in, we can also change this line over here. Now we have changed our function. And in order to see the effect of the change, we have to redeploy the function. So we go through the same steps as before, but it will go a little bit faster. And now it has been redeployed. It should now be able in the response to report on the context. And I'm sending in this curl request, I'm sending in a special header, my special header with as value, my value. Now in the response I'm getting, we should get everything that's in the request in the header, including my special header. So this value is available inside our function and we can make use of it. And of course you can see there are many other context parameters available. And description of everything that's in the function context is provided here in the scenario, so you can take a look. The fourth step, which I won't demonstrate right now, discusses implementing functions in other languages, for example, Java. Java is an obvious choice, especially, of course, with Graal. And the implementation with Graal is in step 5. Here we make use of the ahead of time compilation, which creates a native image. And then finally, the 6th step uses an already existing Docker container image and uses that as the implementation of your function, which basically means that you can implement your function any way you like it, because you can create a Docker container which has basically anything inside of it. Okay, so this is the scenario, and you should be able to get through it fairly easily. At this point, for this scenario, you don't need access to the Oracle Cloud infrastructure. However, for some of the future scenarios, you do, and that's why I should tell you a little bit or repeat what we discussed last week. You have to arrange access to an Oracle Cloud infrastructure tenancy. Either you already have the access, or you should be able to get a free cloud trial using the email address that you've used to sign up for this webinar series. Jürgen Kress, our facilitator, indicated that he has whitelisted over 300 email addresses for all the people who signed up for this series. So hopefully and we had a bit of a hiccup last week, but hopefully when you go and try to sign up for a trial, your email address will be recognized. You are whitelisted. You don't need to provide a credit card, and you will get a slightly higher amount of cloud credits, $500 instead of $300. And then, of course, when you have access to a cloud trial, you can go to the get a code scenarios, and you need to go through the preparation scenario. And we just discussed this last week. If you need any support with this, please ask us in the Q&A window or in the Slack channel, by the way. And here again is the URL to go to in order to get your cloud trial. This basically has the information I just provided, as well as the URL. And then finally, after running the preparation scenario, this is what your prepared tenancy should look like. And the elements that we are specifically going to be using today, in addition to the VCN and the public subnet, are the API gateway that has been already set up after you've done the preparation, this dynamic group, and of course the lab compartment inside of which everything takes place. So now I'm going through the slides that I should have discussed before, and now I'm going to hand over to Rolando, who is taking the project FN functions that we were running locally and runs them on Oracle Cloud. Go ahead, Rolando. We do not actually hear you at this point, Rolando. Oh, sorry. Please go ahead. Apparently, it is my problem. Sorry about that.
pricing. As you can see, the price per call is very, very low. So as you can imagine, probably this is targeted for a constant mechanism of receiving calls and putting them through functions in order for your application to work. But on the other hand, if you have a use case where you may think that functions are a good fit for you, then just take a look to the pricing, because it is extremely low. All right. This is kind of the scenario that we are going to deploy now, or what we are going to follow now. We are going to do very similar steps to what Lucas has just showed to you in terms of creating the function. But instead of running it within the local Caracora environment, we are going to run it and deploy the function into OCI, all right? So that will be the main difference here. We are going to publish the Docker image into the Oracle Cloud image repository. That will be one difference. And the second difference is that the function is actually going to run within Oracle Cloud Infrastructure. So you will see some differences between now and what Lucas just mentioned and showed to you. And in this case, we are going to deploy it in the Oracle Function Service. So as in any other scenario, we have this slide about the why and what we chose this Caracora scenario, or why did we include Oracle Functions for this series? Well, it is, in our opinion, is very suitable for Caracora because both the OCI CLI and the FN SLI actually can do everything about the platform. So you can do a lot of CLI in order to get engaged with the platform. So it is very suitable for Caracora. That's one reason. Function as a service is very relevant for the cloud native development. So if you are doing cloud native development and you are deciding which function as a service platform to use, then this is a good way to start it and get engaged with Oracle Functions. The platform is very powerful and it is very attractive in terms of pricing. So if this is your first time taking a look to the platform, then you can go to the pricing side of the house and you can see that this is very suitable for you. If you already have OCI, then this is a good way to start exploring functions. And if you are looking again for a serverless platform, then this can be an option for you. Okay, that was the why. And what? Well, we are going to get ready for the environment. We are going to prepare the environment for you within the Caracora scenario. You are going to create a function. You are going to deploy the function to OCI. You are going to monitor the function, and you will set some environment variables for your function to get executed, so which is something pretty cool, I think. So I think we are ready to go to straight to the scenario. So this is where we have our 16 Caracora scenarios, and now I'm going to start the serverless functions on Oracle Cloud Infrastructure. Okay, so as in any other scenario, we have a brief introduction. You get the idea of what you're going to get and what you're going to do, and you can just simply click in the start scenario and you are ready to go. As in any other scenario, we need to wait for our environment to get ready because it is downloading the OCI CLI and also the FN CLI. But in the meantime, I'm going to include my credentials right here because we do need the credentials for your tenant. But the scenario needs that. So that's my config, and now I need my private key. Okay. And I think we're ready to go. With the old setting background is already there, so we are ready to proceed. In order to test that I am getting connected to my tenant, I can execute this. So this is just returning the namespace of my tenant. Keep in mind that for this scenario, we need to include not only the normal or the default, entry for your OCI config, which is the default, which is this one, but you also need to copy that one and just change the name for FN because we are going to use this entry for the FN, the Oracle Functions service, all right? This is exactly the same thing that Lucas did, which is just to get the version of the FN CLI. He listed as well the context and he explained why he was using the local one. But in this case, we need to create a new context, which is going to be named Oracle. We are actually going to use this context for our scenario, and we are going to point that context into the Oracle Functions service, all right? So we are doing all these clicks to set the environment just because of that. So we are getting the VCN's IDs, the subnet's IDs, the name space ID as well. And with that, we are going to update the context, all right? We have already updated the context and we are going to list it again. And now the difference is that we are going to use Oracle context, which is the name that I gave. And as Lucas mentioned, the star is pointing to the one that I'm using now, which is this one, all right? Okay, so I think we are ready to proceed. Then, because we are going to deploy the Docker image to the Oracle Cloud image repository or registry, we need to get our username for that, all right? So we are going to get it with this execution. If you don't have your token, you can create it right here. That is why we included this link here, because if you don't remember the token that you need to use in order to connect to the Oracle Cloud image registry, then you need to go here. I already have it. I am going to skip that step in order to proceed. And now I'm going to log in to the Docker registry. I already have my user, which is this one. Okay, we got this for you through the execution of those environment variables, and now I am going to connect to the oh, this is wrong. I don't know why. Okay, let me just change it. I am connecting to Ashburn, so it's IAD. This is my username. I am going to stop sharing my screen because I am going to copy my password, and that's sensible. So let me just stop this. And let me just copy my password. And I'll be back with you in a minute, okay? All right, I have it right here. Okay, let's get back. Okay, so we're back. Sorry, I think I already messed it because it was already there. And okay, login succeeded. All right, so let's continue. Let's move a little bit faster. So we are ready to create our function, which is exactly the same thing that Lucas did. I am going to export an environment variable. Let me just change this ID because I've been redoing this scenario many times, so I already have used many of the IDs. So let me just export this variable. This is just for you to get control about what you are going to deploy. And we are...
Did you really do it 75 times?
Not so many times, but was the last one. But believe me that I've been doing this for the last month. So anyway, the thing is that we are ready to create the function. This was explained by Lucas. So we have now, let me just change to here. So we have the manifest, which is this YAML file, which just represents whatever describes our function. We have the function itself, which is that .js file, and we have the package.json, which Lucas has already described to you. Okay, now we are going to create the application. The application, it is a way to concentrate your function. So it's like a logical container for your function. So it is like a logical container where you're going to incorporate your functions. Okay, so we are going to create one application and we are going to deploy our functions within that application, all right? And that application is actually going to be the lab and the variable that I just said. Okay, I don't know what happened right here. That's weird. Okay. I don't know if you identify what happened, Lucas, but let me check. Okay. function.oci. I think there is an extra character right here, Lucas. You see it?
Looks like it.
I don't know why.
Although,
yeah, I don't know. I think it is related with here, but I think I know what it is.
oh, things like the region doesn't have a value.
Yeah, that's weird. And this is the error. You can see it, right?
Yeah.
Let me, yeah, I think we can fix that. Let us try just to fix it just for you. And so we can continue. So this is the place where we are actually doing the update context for the API URL. So I think we can update it with this. Okay. All right. So should be like this, and the okay, we can do the FN update context file. Let me see if it's already fixed. Same thing. Okay. I don't know what happened. I've been doing this, as I mentioned, like tons of times. You know what is it is this one, right, Lucas? I think the one that I need to execute.
Yeah, but where's the value set for the region environment variable?
Yeah, I'm gonna change it right here. And my region is. Oh yeah, I know. This is such one.
Yeah.
That's right. Okay. So yeah, I don't know why it didn't get the region. It's weird. But I think we are ready to go now. We just need to update the context. Sorry about all this thing. It's hard to making it live.
As Holger is pointing out, we are all learning a lot through the error corrections because it's the kind of thing that we all will run into, of course.
Okay, so I think we can create the app finally. And we were ready. Okay, we are ready. Now we have the application. Sorry about all these things. And we can list all the applications that we have now, which is, I have 3 applications already in my tenant. This is the one that I just created, Lab 76. And now I'm going to deploy to that application the function that I just created, all right? But I think we have the same thing right here for the registry. I don't know why. No. I think, which is console. I am just going to reset the variables now that I already have the region variable, so probably that can help me. And this one's well. Okay, let me see if I can now deploy it. No, okay, I want to set it manually. I don't know why it was not set. FN registry equals. Now I need IAD dot, which is this one. Hopefully.
Type in additional.
Okay, all right. Let me see if with this one we can move forward. Okay, so what are we doing? We are packaging the function within a Docker image, and we are actually registering the image into my Oracle Cloud image repository, as you can see here, which is iad.ocr.io, and it is deploying the function into my application. Okay, so it was successfully created. So now we have a function within the application. All right. If you want, or if you are curious about what happened with the Docker image or what is the Docker image, you can issue this, and you can see that the Docker image was created and it was tagged. So we have it here locally. Okay. Now, just for you to see where your function was registered within OCIR, you can get to here to the registry, and you can just browse here. We have the hello 76, and we have our image right here. Okay. So everything that we did, it has all these layers, and it is already deploying to us here. All right. So now let's just get back and move a little bit faster. So now we have we can list the functions that we have. And we have this function hello 76, and now I'm going to invoke it. So with the way that we invoke it is through the application name and through the function name. So our application name is lab76. It is sold in the environment variables, and the function that we just did. Now it is doing the call to start, which is the same thing in any other function as a service platform. All right, we have a time for the call start. And it depends on how fast Oracle creates everything in terms of the infrastructure, and then how fast your application is able to start. So it depends on those two variables, the infrastructure and the time for your application to start. So it took like maybe 15 seconds or so, which I think is something Oracle is trying to improve. But now if you invoke it again, then you can see the result pretty straightforward. Okay. Now I am going to send a second request, but with my name, just for you to see that this is working exactly as expected and as the way that Lucas showed to you in the first scenario. So if I do here a Rolando, so now it's going to reply, hello, Rolando. Okay, I can inspect my function with this command line. So I can inspect what is my function all about, where it is located, in which compartment ID, what is the application ID, and so some other useful information. And you can also monitor your function. So we are getting you this direct link for the function side of the OCI, and then you can go to metrics or to metrics, and you can see some of the information about how many invocations we have had, the duration of that function call, and so on. Okay, so if I redo many times this thing, then you will see that I am getting more calls and more calls, and you can actually monitor them here. Okay, so it's not here, it's in this tab. So if I do a refresh, then I can get a different set of metrics within the OCI console. Okay, so now we have more. All right, we have more than 3. Okay, so let's continue, and then I think we can start wrapping up this scenario. Now I am going to invoke it, but through the OCI CLI, which is, remember the whys and whats that we are including. This is another reason why we included this, because you can incorporate the call of your functions, but within the OCI CLI. So the OCI CLI is pretty powerful. It is not just only for operation or management, but it is also to get engaged with your services. So in this case, as you can see, we are using OCI CLI to invoke my application. I am listing, okay? And with this, I am invoking it, okay? So we are doing kind of the similar things of what we were doing through the FN CLI, all right? And this is also something good to mention, that this call, if you are trying to do a call to the endpoint that you get from listing the function details, you will get an error because you cannot call directly the function because this needs to be signed. And this is something that is documented, and there is so many blog posts around how you can invoke it with a signed request, okay?
But better yet, you get an API gateway.
Yes, correct. that is what we are going to show in the next scenario. You can do this through the API gateway, and it is pretty simple, and it is very, very straightforward and powerful. And I think the last thing that we are going to mention in this step, in this scenario, is how can you configure some environment variables for your functions. So we are going to open the code actually, which is within this folder, the Hello 76, and just follow this instruction. So we are going to copy this line, and we are going to put it as the number 4 here. Okay, and we are going to replace the last line right here. So basically what we are going to do is to create an environment variable that we are going to inject into the function, and we are going to retrieve it within our code. Okay, so we are changing the code. Lucas already explained it. In order to get this code updated in the function, we need to redeploy it. So here we go again. We are recreating the Docker image and redeploying the function into our OCI platform, all right? So it is just creating the image and pushing it to OCI and deploying it to Oracle functions. Now we can invoke it, okay? But the result will be pretty much the same thing. But now we are going to use, we are going to configure the environment variables. So the greeting is going to be high. So take a look at here, the variable was greeting, and we are putting or pointing it to high. And now we re-invoke it. Now we have, instead of hello, we are going to get a hi world, okay? If now we change it to another language, now we are going to get this. Okay, I don't know French, but
bonjour mon ami world.
Okay, so Lucas does, so that's the way to pronounce it. And pretty much that's it. We can update actual greeting at the same time. This is obviously something Lucas is going to do.
Yeah, this is Dutch. Goedendag. Okay.
So now it is responding with this other greeting. And that's it. That's the scenario. So what we learn is Oracle functions, it is created, part of it is created within the FM project. You can do whatever you can do with the FM project locally, but you can deploy your functions into the Oracle function service, and you get this type of experience. Remember, this is a serverless function as a service platform. So what you need to focus is in your code, and everything behind the scenes in terms of the infrastructure, networking, even the Docker image, it is not on your end. It is on the cloud provider end, okay? So I think we can continue now, Lucas. And sorry for all this variable thing. I really don't understand what happened, but we were able to fix it, okay?
That's so fine. That's just the way of the world. That's how things work.
Absolutely.
Okay, we already mentioned the API gateway, and it's several things. And one of the things it is something we really need with our functions and for our cloud native scenarios. So the API gateway handles HTTP calls, and it can do a number of things with these calls. It can route them, and in the end, that's the most important thing it will do. It can also authorize the calls to make sure that they should be routed, and it can map bits and pieces from requests to make sure that they end up in the right format at the endpoint. And then the API gateway can do monitoring and auditing. Now, this may sound a bit familiar. People in this session may, for example, know the API platform. And of course, it is related, but then again, it's completely different. It's completely different underlying technology. It's completely different price model. This API gateway is far more lightweight, and it's far cheaper too. It has been in existence since December. It's a fairly new addition to the OCI portfolio of services, and it's a crucial addition. So here in the diagram, we see a service invoker, which can live inside the Oracle Cloud Infrastructure or anywhere else. It could be Postman on your laptop, or it could be an application running on a third-party cloud or on-premise somewhere, and it sends an HTTP request to the API gateway. And the API gateway typically will be associated with a subnet that's public and that accepts requests from the outside world. It's one of the reasons why the scenario you're going to do might fail. For me, when I was preparing for the demo, it failed because I didn't set up the ingress rule, and that's something that's part of the preparation lab, but you need to have an ingress rule for traffic on port 443, HTTP traffic. So the API gateway has API deployments, and API deployments are definitions of endpoints, basically, of routes and endpoints. And one of the types of endpoints that's supported is the stock endpoint. And we will see this in a moment. Stock means predefined fixed response. So it's mainly there for testing purposes or for mock implementations of APIs, but it's very handy to get started with. Then the API gateway can route and map, authorize, and monitor to any third-party HTTP endpoint, either inside Oracle Cloud Infrastructure or outside of it. So any HTTP endpoint that need not be exposed to the public internet can still be invoked from the public internet if the API gateway routes to it. And that's one of the easiest ways for us to invoke functions as well, because the API gateway has very good integration with functions. It's a natural combination. To be able to invoke functions from outside the Oracle Cloud Infrastructure, we simply make sure that the API deployment on API gateway defines a route to the function, as we will see in a moment. So here are some of the things that the API gateway can do. It exposes private endpoints in a public environment. It can provide stable endpoints because the API gateway takes care of the endpoint, and we don't rely on the current implementation. So the same public endpoint at this point can route to a stock API or a mock API, and at some other time to a certain version of a function, and later maybe another version of the function, or even a completely different endpoint, such as a container running on the Oracle Kubernetes engine. The routing is defined based on verbs, wildcards, and path. And we can use parameter and header mapping. And we won't go into all the details today, but this is all the things that you probably would expect from an API gateway as well. We can define a number of request policies, and one of these is rate limiting. So we can implement throttling to prevent a too large number of requests being routed by the API gateway to the endpoint. We can make sure that the response contains coarse headers. And as I said, we can implement monitoring and logging of all the traffic through the API gateway. And finally, there's authentication of requests. So the authentication is implemented using a special function, which is called the authorizer function. And basically, here we have a route through the API gateway to a specific backend. And to make sure that only authorized requests are flowing through this route, and now I have to relocate Rolando and show myself perhaps. Any backend can be protected with this authorizer function by specifying the authorizer function on the API deployment, either on a specific route or on the API deployment, which is a cluster of routes in total. I will show you this in a moment. The authorizer function is a function, and now we know how to define functions and how to deploy them. And this function basically returns a response that says true or false, allowed or rejected, and it can return some other information as well. So when the service invoker makes his request, he will typically include in the request a token, for example, the JWT token, or some other specific header value, and that information is passed by the API gateway to the authorizer function, and then used in the authorizer function to determine whether or not the request is allowed. So the JSON returned by the authorizer function is currently not embedded in the request to the backend. And that's something that I've logged as an enhancement request, if not a bug, with the Oracle API Gateway team, because I think it's important that the authorizer function not only says whether or not a request is allowed, but also provides information about the identity of the service invoked. So that's currently not available, or at least it wasn't last time I checked. API Gateway is fairly cheap. At least you can start at a very low price level compared to, for example, the API platform. And it's my feeling that in the midterm, API Gateway is going to be the way forward for Oracle, and the API platform, the design capabilities for API platform may probably stay around, but the actual API Gateway implementation is probably going to be the one that we are discussing right now. That's the one that fits in much better with the cloud native model. So our scenario on the OCI API Gateway, the hands-on scenario, well, why hopefully is clear by now. The API Gateway is the consolidated and decoupled entry point to services running on OCI or on other backends. Basically, if you want to invoke a service, whether the service is a function, a container, a virtual machine, or a third-party backend, go through the API. Go through the API Gateway. That's your one-stop entry point to your cloud-native environment. API Gateway integrates very well with OCI functions, as you will see in a moment. It's a key component in the cloud-native implementation. That's why we're discussing it already in this second installment. And it provides a number of policies. So what are we doing in the scenario? Well, the lab environment already contains the API Gateway. It was created in the preparation scenario. It's not very hard to deploy one, by the way, but we thought it's easier for you to have it already set up. And I can show you right here that you should have an API Gateway that looks something like this. So we go in the menu and we go to developer services. You will find API Gateway right with functions, right under the container registry. And here is a list of all my API gateways, or at least all the ones in my current compartment, the lab compartment, which is the one you should be using as well for doing the labs. And the gateway, well, there are some metrics. And there are no deployments. Well, there used to be 2 deployments, the ones I created earlier today when I was preparing for our session. But at the moment, there is no API deployment. There's no set of API routes that's defined on this API gateway. And that's something that we will do in the scenario, define this API deployment, first with a stock route and a regular HTTP backend, and then with a function. We will, of course, test the routes on the API gateway, and then we can also inspect the logging if we define that the API gateway should implement logging. So let's go to the scenario. And I have already set up the connection to my OCI tenancy and defined the environment variables. I use this command to get information about my API gateway. That's the same information you just saw in the console, but now it's returned as a JSON object. Here's a list of all the API deployments on the API gateway, and there are none, as we have seen before, except for the ones that have been deleted. For some reason, they stick around. I'm not actually sure why. So now I'm going to create a new API deployment. And I'm first creating a file that will contain the definition of my API deployment. So that's this file. And here I'm copying the definition of a single route. I can create the same thing in the console, by the way, if you find that easier. And I used to find that easier, but now I'm all about automation. So here we are defining a route of type stock response backend. And here is the response we define. So this is a static response. We will get this every time. It's defined for the get method. So at this point, no put, no post, no delete. And the path to this particular endpoint is the path /stock. So using this deployment file, I will create the API deployment. And it's currently being created. So the status is creating. It's not there yet. The request has been made. The status is creating. It will take up to, as I say down here, 15 to 20 seconds for the API gateway API deployment to be created and ready for action. So we see that the current status is creating, and I can take a look at the definition. And well, currently no metrics, and I cannot open, but now I can. So now I can take a look at the definition of the routes, and I will find the single route that was just defined in the file, in the JSON file, and I automated the creation of the API gateway deployment through the JSON file. So that it exists, we can invoke it. So we first need to get the URL for invoking it, and then we can make the actual call. So the URL is now in my environment variable deployment endpoint. There we go. So this is the endpoint of the API deployment on the API gateway. /stock is the route. Let's go to my browser. My browser is not connected in any way to the OCI tenancy. So I'm just on my local machine. I'm coming in from the public internet. And the question now is, of course, will I be able to invoke this URL or won't I? And I am, and the result is immediately saved to a file. And I can then open the file. Maybe it's more convenient to use Postman. It'll take some time to start up, so we will return to the scenario at this point. And you will here get instructions about going to the API gateway in the console to check on the metrics. So I cancel over here, and I check on the metrics, and these are refreshed every minute or so. So let's make a few more calls down here. Call, and that's the wrong one. So now I expect some metrics to be available to indicate that a number of invocations has taken place. There we go. Well, it's not a very large number, is it? It will be refreshed in a few minutes' time. So returning to the scenario, we're going to make the API deployment a little bit more interesting. We're going to add additional backends. So I'm creating a new file, as you will do when you go through the scenario yourself, and open the file and copy the definition. So there's still the stock backend, but now there's also this search backend, which routes to an external website. And there's this countries endpoint, which routes to a file somewhere on GitHub. So here is my configuration for the API deployment. And now I'm going to change the existing API deployment based on this configuration. So I have to indicate that I'm willing to override what's already there. The work request is now being processed. And again, it will take some time for the API gateway to be updated. So the current status for the deployments, here we go. So the state is active. So it's done. It should be available. I can check the definition of the API deployment again, but that's not going to give us a lot of additional information. Let's try to invoke the new routes. So here I'm invoking the search path. And as you can see up here, it will give me the contents returned by this website. Will it work? It does. That certainly looks like the contents of a web page. Let's check if we can get a list of countries. There we are. So this is the countries route, which is forwarded to this file on GitHub, and the contents of the file is returned. And of course, as before, I can copy this URL. Well, actually, I can even open the URL simply by clicking on it. And again, from my browser, that has no connection to the Oracle Cloud. Because the API gateway is publicly exposed, I'm able to get to this third-party endpoint. Now, finally, the functions. I have a function called hello, as you will after doing the scenario that Rolando just demonstrated. I need to get a list of all the functions in my application. And if I have the function ID, here is the function ID, I can now create the final definition of the API deployment. So that's yet another file. And click here to add the contents to this new file. And in this file, you need to edit a little bit more. So please pay attention. Here, the function OSIT needs to be replaced. Needs to be replaced with a value that's down here in the terminal. Copy. Paste. And now I've set up a route that's activated by the URL path hello for the methods get and post, and it's of type Oracle Functions backend. And this is the function ID of the function that should be triggered by a request that goes through this route. I think it's fairly intuitive. Maybe I've been doing this too many times, but I think it's fairly intuitive. So let's redeploy or reconfigure the API deployment. I have to confirm again that this is really what I want to do. Work request is being processed. And when the processing is done, now it's updating. When the processing is done, I should be able to invoke my function, not just from the OCI CLI, not just from within the context of Oracle Cloud Infrastructure, but from anywhere in the world. In fact, you are able to invoke my function, and I will put the URL in the chat window so you can try it out yourself. So it's active. Let's invoke the function. There we go. Cold startup will take a while.
15 seconds.
Oh, it shouldn't take that long. It's actually taking a bit longer than I would expect it to take. There we go. Just as I'm despairing, it's coming up. And now when I try again and again and again and again, you can see it's much faster. So it's really pretty slow that first time, isn't it? I'm collecting a lot of metrics. And here is the endpoint. So I will copy this endpoint to the chat window, the Q&A window. No, chat window makes more sense, of course. There we go. And you should all be able to invoke my dear function hello. So it's a function. I've created it in my environment. I've deployed it to my environment, and then I've exposed it through my API gateway, which is accessible on the public internet. So you should have access to it as well. Well, that completes this scenario, or at least the parts that I'm going to demonstrate. And the other, for example, the logging is something it's described in this in the scenario, please find it out for yourself. Basically, you have to configure on the API deployment that you want to have logging. You have to specify at which level you want to have logging, and then log files will be created in your object storage account. So this completes our demonstration and introduction of services for today. A few important URLs. First, thecloud.oracle.com/try it if you do not already have your cloud trial. Remember, if you go to this URL and you use the email that you've used to sign up for this webinar series, you should be whitelisted and you should get your trial without using a credit card and with the $500 account. And of course, the other URL takes you to the Katacoda scenarios where you're able to do the same hands-on that we have just been demonstrating. The session sorry, go ahead, Rolando.
Yeah, about the Slack. If you have any questions after the webinar and you are doing on your own just the Katacoda scenarios, you have right here the Slack URL, so you can contact us through there. Okay.
Very good. Rolando and myself will be available for a little longer to help you through the Q&A window. The session has been recorded. I will stop the recording right now, and we will make that available later today on YouTube, on the real channel, the Red Expert Alliance channel, for you to watch again and again and again. Thank you very much for your attention. Thanks for the collaboration, as always, Rolando, and thanks Jürgen Gress for facilitating us with this session.
Thank you. Thank you. Sorry about these variables thing.
Not a problem. Not a problem. That makes it real.
Yeah, actually, it makes it even better, so you can understand where can be the issues, right? So, but anyway.
Jürgen, hi, Lucas and Rolando. Special thanks. That was wonderful. Great job.
Thank you, Yuri. Thank you.